My name is Matthew Geronimi, and this is my assessment task for EDU 4002. The project I've created used both digital and physical technologies to address contemporary sustainability and environmental issues following the Creating Design Solutions strand of the Design Technologies curriculum, and an emphasis on design-based thinking, real problem solving, and evaluation. For this task, a Melbourne Eastern Suburbs Council requires a system that facilitates improved locating, monitoring, and maintenance of street trees that have been recently planted. At this point in time, the trees are planted annually, but ineffective post-planting management due to an inability to locate or regularly assess the trees results in dwindling survival rates. The client is looking for both a solution that is accessible for both council workers and community members, so they can collaborate, it has a high level of durability in exposed environments, and is cost-effective and easy to replicate. And this in turn benefits the sustainability and urban canopy coverage for the area. The problem is relevant to the UNSDG's Goal 11 for creating sustainable cities, and the solution aligns with the investigating and defining substrand of the creating design solution process, wherein students identify needs and opportunities. The product and design process demonstrates the analysis of a contemporary sustainability issue and a design-based process that makes an ethical approach to promote sustainability through engaging the community to maintain urban ecosystems. There are currently several products in existence, such as the Marybeck Council's Tree Plotter webpage that allows the council to register tree and community to locate them. The app iNaturalist that allows community members to track the status information pertaining to trees, but has no real council-based usage and thus lacks the ability to function as a dual usage system. Alongside this, the graphic information system currently already in use for councils to track tree data, yet it does not allow the benefit of community input and collaboration. The issue as of now is that none of these systems have been amalgamated together, wherein the community members and council have a way to combine assessment and assets and engagement for the betterment of the system. Unlike these systems, my proposition has both community status tracking ability, community feedback ability, and council register ability, and a hub space where all these components work together. As part of generating and designing through evaluating and refining multiple ideas, I had mind mapped and conjured up modes such as QR tagging and adopt a tree program, soil sensors, and drone surveillance. The evaluation of these ideas was checked against 4 criteria: effectiveness, cost, data accuracy, and accessibility, which were then refined and selected based on the most optimal outcomes. The prototype that offered the best return as a low-cost, accessible, and effective solution that can be used as a help for both council and community members was the QR code-based mobile app I had created, known as the Canopy Tracer system. While soil sensors and drone surveillance had a higher data accuracy, QR code tagging was chosen as the most suitable solution by me due to its lower cost regarding maintenance and product creation than the soil sensors and drone surveillance, higher effectiveness in the upkeep of trees and adopt a tree program, and a greater accessibility to both council and community members. Drone surveillance also risks community disruption as they're often loud and come with added privacy concerns. The system works by attaching durable metal QR code tags to the tree upon planting. At this point, the council will log individual information to each tree planted. Users will then be able to create an account to reduce spam posts on the app and register with the council to provide updated information on the tree species, condition, height, structure, age, damage, habitat usage, and further statements or feedback. This provides a continuous monitoring system that will fill in vital information for periods when the council workers cannot track the trees. Outside this, council workers will update their own information on a periodic basis. Every 4 years, as a tree grows, the tags will be adjusted so not to constrict the tree's growth. The model provided showcases the functionality of the system to align with graphical representations for generating and designing. The model utilizes labels, diagrams, and a flow structure to communicate how the QR code, users, and database elements interact and function. This is my model. The materials involved in the process include the stainless steel, weather-resistant QR code tags, and rubber expandable loops to attach to the tree trunk that function without damage to the tree. On the technological aspect, the mobile app itself and the council database are appropriate for the collated information. These were chosen and designed to be durable in an outdoor setting and sustainable for their reusability. The materials chosen are all reusable, weather-resistant, and reduced waste bioproducts to support sustainable design practices. Stainless steel was selected particularly due to its long-term performance and the lack of the need for regular replacement. For the producing and implementing component, if the production were to go ahead, the system would require the creation of QR code tags and an attachment material, the rubber, the development of the Canopy Tracer app and the database for the system. Following this, a testing phase would be conducted on a small scale to identify any weaknesses or unsuspecting benefits to adjust the system where appropriate to maximize this effect. A risk assessment was undertaken by identifying hazards, analyzing their likelihood of occurrence, and the potential consequence of each hazard during installation and usage, such as injury, tag damage, cybersecurity issues, and weather exposure. The likelihood of and risk of each factor was combined to offer insight into reasonable control measures to take. For example, the installation of the tags presented a medium likelihood of injury, such as cuts. To minimize these risks, control measures such as sun protection, PPE, and usage of durable gloves have been implemented. This relates to the safe working practices as part of the producing component of design solutions. More information is available on the slide. The STEM concepts integrated into this project include the science applied for understanding how ecosystems function and can be improved, and environmental sustainability. The technology component is evident in the QR code and digital technologies. The engineering component is undertaken in the QR code tags and the materials for mounting and maintaining durability in an exposed environment. And the mathematics component is evident in the assessment and monitoring of data facets, such as the tree height, width, age, over time. This aligns with the STEM learning elements supported by the Victorian Curriculum 2.0, where students will apply STEM knowledge to generate, produce, and then evaluate real-world problems. The Canopy traces system adheres to the request of the client by providing effective monitoring systems to assist with the maintenance that engages community members and provides data that can inform future decisions regarding species selection, maintenance decisions, and planting locations. The strengths of this system include its low cost and large-scale applicability, improvement of previously insufficient monitoring regularity, and its emphasis on community engagement. The limitations of the system can be reduced to the reliance on the community engaged participation, wherein data may not be always consistent, the subjective nature of community feedback, destruction of QR tags by the public, and irregular nature of updates by community members. Future improvements may potentially include the implementation of sensor features in targeted areas where required if they are not receiving as much community input or being vandalized, and the incentivization for participation by community members. As a whole, the design meets the requirements posed by the client, yet is open to further future improvement based on its performance. The process reflects both the iterative and evaluative process of creating design solutions. And these are my references.